Okay. Hi, everyone. Yeah. Can you hear me and can you see my screen clearly?
Yeah, yes,
Yes,
Sandeep.
Sandeep, we can see.
Perfect. Perfect. Okay. Okay. Perfect. And yes. All right. Let me, first of all, welcome all of you. Welcome to this nice session. And what we're going to do is we're going to cover these topics. We will do a brief introduction about the various, the professors involved, institutions involved, as well as we will go through the introduction of data science, machine learning, and AI. And we will also talk about the various applications and a brief about ChatGPT and so on. All right. This is going to be approximately 2 hour session. There might be a 10 minute break. We will most likely skip the break today. And except for the speaker, everyone is on mute. So please use the Q&A and there's is there a Q&A thing? No, there's a chat option for all of you since you have all joined it as a meeting. So use the chat option to ask questions, and don't worry, the recordings and slides will be shared after the session. They'll be put into the LMS as well. So you don't have to worry about the you don't have to worry about screen recording and so on. But feel free to do the screenshots, or if you want to make notes, feel free to do so. And yes, all right. So thank you, everyone. And right, we want to give brief introductions about various people involved. Professor Manhas, are you able to hear? Are you available, or do you want to introduce later?
Yeah. Good morning. Sorry, good evening. So, yeah, I'm there. I'm just listening to you. So, thank you. And first of all, let me say hello and warm welcome to all the participants. I'm heading this initiative at called Electronics and ICT Academy, and we, in partnership with the CloudX Lab, are offering this program. And this is, I think, third batch that we are now starting, and I welcome all the participants. And we have carefully curated this program, looking at the aspects of AI, data science, machine learning, and also its integration with new technologies like Chat GPT. So I'm very sure that all of you will do well learning this program. Yeah. So
Yes.
over to you. Yeah, please.
Okay, okay. So, yeah, I wanted to introduce Professor Manhas. Okay, so Professor Manhas is a professor at EC Department, IIT Roorkee, and he's also a chief investigator for ENICT Academy, IIT Roorkee. And Professor Manhas comes from, we have CloudX Lab and EICT Academy. Thanks to Professor Manhas. They have collaborated and worked together for more than 5 years now. Okay, I'm just trying to modify this. Okay, so yeah, those who have access to this, can you change the spelling of Roorkee? Okay, and and previously, Professor Manhas has also worked with Micron Technology as a member of technical staff, and he has a PhD from De Montfort University, and he has an MTech from IIT Madras. So let me introduce Professor Tarun. Professor Tarun is going to be a faculty and leading the classes, and Professor Tarun is a faculty in EC department, IIT Roorkee. And previous to previous to getting into academia, Professor Tarun has worked with Brainwave Science Incorporation, and he was assistant professor at IIT Dhanbad, and his MTech and PhD and BTech, all three are from IIT Kanpur. Um, uh, and we are, you know, lucky to have Professor Tarun teaching this class. He is quite passionate about machine learning. And Professor Tarun, would you like to say a few words?
Yeah, a very good evening to all the participants for this PG course on AI and data science. Especially, I would like to thank CloudX Lab and EICT Academy at IIT Kanpur, sorry, IIT Roorkee. So, we basically work on intersection of data science and biomedical signal processing. So it would be so I have taught two batches of the current course over the past iterations of the same course. So I am looking forward to interacting with all of you and contributing to the learning trajectory in this course. Thank you.
Thank you, Professor Tarun. All right. Um, would you like to give an overview of IIT Roorkee? Yeah.
Professor Manahas is there? Who's left?
Professor Manas, would you like to go over? Or you go over. I think he'll give an overview of PNICT. So you please go ahead with.
Yeah. Yeah. So, so I belong to the Department of Electronics and Communication Engineering at IIT Roorkee. So it's my pleasure to introduce our institution here. So IIT Roorkee is one of the oldest technological institution in Asia. It's established earlier as Thompson College, and it was in 1847. So currently we have around programs, 11 programs in bachelor's degree which are offered, and also postgraduate degrees are offered in 55 disciplines. So there are various departments and various centers of excellence which are funded by different industries as well as government agencies. So we have 23 departments and 9 center of excellences. And also we have a school which is equipped with uh, very world-class lab structure, lab infrastructure, and global, globally acclaimed central library. So we have students also from of international background in the sense that we have students from more than 50 countries joining IIT Roorkee for full-time and short-term training courses.
Thank you. Yeah, please go ahead.
So these are some of the documented achievements of IIT Roorkee. So IIT Roorkee is one of the very premier technological institutions in the country, one of the top premier IITs in the country. So, so IIT is known for specialized research in some of the areas of interest or specific interest in of the nation. So we are ranked in the parameter known as citations per faculty in the QS World University Rankings 2021. We are the top among the IITs, and so in the Asian University rankings, so from Times Higher Education institutions, so we ranked 83rd. And among NRF rankings, we ranked 6th across the country. And so so among world universities in the QS World Ranking parameters, so we have again ranked in the top 20, the QS World University rankings. Okay. So, yeah.
All right. Thank you. Thank you, Professor Tarun. Yeah, I want to give an overview about myself. I am also from IIT Roorkee, and this is probably the best memory I have had with IIT Roorkee. I did my graduation from IIT Roorkee, and the I have mostly worked on large scale computing. And previous to starting CloudX Lab, I worked with Amazon, InMobi, and DigiShop. At heart, I love explaining technology. I have even in a dish or everywhere, wherever I got a chance, I taught some class or the another, even at Amazon. Whenever I got a chance, I taught something. And and I'm a software engineer at heart, and I love machine learning. I have been doing machine learning since probably at the time of InMobi. At InMobi, I started doing machine learning on large scale, and then afterwards at Amazon and at CloudX Lab, we have done a lot of machine learning work for various companies. As of today, we work with multiple um, medical science companies, medical sciences in pharma and healthcare, whereby we help them build models in order to extract information and in order to do the pharmacological research. So CloudX Lab works with multiple companies in order to provide them machine learning and data science the data science research as well as engineering consulting for various top companies across the world. So along with running these courses, we have excelled at now delivering very large scale project into the data science. And for past 1.5 years, we have put top students from our class as an intern as well as a full-time engineers into these new projects. So some of our current clients are McKesson. Examples of that is like McKesson in the US, and a few more are coming up. So we are working on those interesting ideas in medical sciences. And about CloudX Lab, we basically the core vision is to upskill engineers and IT professionals across the globe in deep tech, machine learning, big data technologies, and make them employable and future ready. That's the core idea. And for that, what we have done is we have built a full playground whereby on the left-hand side, you would see the theory, and on the right-hand side, you would see the playground. This playground is uniquely designed for the data science kind of work. Unlike our usual coding work, the interface is more about interactive programming. On the right-hand side, you can keep on doing the interactive programming, and the system keeps on checking whether you are doing well or not. On top of the hands-on assessment model, we have something like you can launch your own terminal, you can do your own work. So it provides you with access to all the tools. You are not bound by a particular technology. There are almost every tool is installed on the lab. So you can do a combination of things like, can I run this particular tool on Spark, right? The data engineering one, and so on. The lab is used by everyone across the globe, including the MITs. They use my lab. And we have been maintaining and taking care of the cloud-based lab. And more than 300,000 people have so far used the lab across the globe. So, lab as well as our courses. The lab provides you a real world experience in the sense that when you join a organization, this is the kind of online cluster you will get access to. So you get used to the lab environment right away. And unlike assuming that there'll be a Windows computer and then you'll have to use a Windows computer, there'll be mouse and click. No. Usually when you join an organization and work on a large company, you will get an environment more like what you see at CloudX Lab. There could be a notebook environment, there could be an interactive like terminal environment, and so on, like the black screen that you saw, that kind of environment. So it's very close to the real world experience. It's a seamless experience, as in you don't have to install and download. The core idea of CloudX Lab came when we launched our big data course, and nobody in my first batch could install the Hadoop and Spark and MongoDB. Nobody was able to install it for like 20 days. So we set up the entire cluster, and then everybody has started to using a shared cluster, and that became very successful. We were the only one to give that hands-on experience and seamless experience to people. And this is when everybody started, renting out, or you can say they started using our lab for their own classes. So and people across the globe still are using this for their learnings. There is a central data set whereby you can put all your data sets at a central place. I mean, we have put almost all the data sets that are needed for the course at a central place. You don't have to go anywhere. Further, you can use it from any device, any browser. You can do the SSH, you can do even the notebook can be opened from the phone. Further, on top of it, at CloudX Lab, you will find that there is a profile, there's a forum, you will see that lots of people are using it, and there's a discussion going on underneath every exercise. So you can scroll down and see what people have tried and what people have been doing. And if you put your question there, somebody will answer. So, and on top of it, what we do frequently is we post jobs. We basically, when companies come to us, we basically share the jobs. From time to time, we conduct something called exam. It's called placement eligibility test. You have to attend to this test. It's a proctored test. And then we do the job matching. And based on that, we connect you to the recruiters, right? So with that, I want to start off with talking about the data science. All right. So this was about CloudX Lab. We talked about IIT Roorkee, about EICT, about CloudX Lab, and we would like to now start with the core agenda of the class. So, what exactly is data science? So, data science is essentially a very wide field, or it's an interdisciplinary field. When I say interdisciplinary, it means truly interdisciplinary. The people who I'm working, as in people that I work with in our CloudX Lab project with the industry, I have people from every background. There are people who are from the law background, studying data science and working in data science. There are people who have been throughout doctors. They are working on uh, using the data science in order to diagnose the disease, diagnose and coming up with a cure and so on. So data science is truly interdisciplinary field, and I urge everyone from every background, whether you are in human resources, whether you are in law, you are from artist background, you are an artist, and or you are a musician, you are a doctor, whatever is your background, I urge everyone to get comfortable with the field of data science, because data science overlaps with everything. Whether you are in marketing, you are in sales, you are in uh, healthcare, and so on. Everywhere you will find the data science. This is the tool that is commonly usable. This is the knowledge that is most powerful across all the domains. So it's an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structured and unstructured data set. Okay, so from anything starting with, right, almost every field you will find the data science applicable in. Okay, now to be great at data science, you will need some knowledge of math, some knowledge of computer science, some knowledge of particular domain knowledge. If you are, let's say, working in medical healthcare, you will need some knowledge from the healthcare, and then you will need the statistics. So basically, the data science is a combination of multiple disciplines, right? Now, the other term that you would see often is the machine learning. What exactly is the machine learning? Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Now, here's a very important part. So the world has evolved is we were doing mechanical engineering before, right? Mechanical engineering, as in we were building watches and so many other mechanical things that we were doing, right? Civil, first we did lots of civil engineering, then we did lots of mechanical engineering, then we did lots of electronics. We created the logic using the electronics, right? If you want to get things done, if you want to build, let's say, wash clothes, we build the electronics logic, right? So then electronics, then came computing. In computing, we coded the logic by hand, right? We coded the logic by hand. We wrote like, if this is this, then do this. If this is this, then do this 20 times and so on. So we wrote the code. We wrote the code, right? We explicitly gave instructions to the computer. But with machine learning, what we do is we let the computer learn from the data. The computer, we basically hook it in a way that it looks at the data and learns from it. And then you don't have to code it as such. Instead, it learns from the data. Okay. So this has been the most powerful thing in in the recent times. You can understand the gravity of machine learning from the fact that the Nobel Prize, the last Nobel Prize, in which the protein synthesis was done using the machine learning, using the AlphaFold. Okay, and that has been the big breakthrough, which is an intersection of chemistry, biology, and computing. Okay, so machine learning today has given much better results than usual coding, right? When people wrote the code, they knew the logic, how to get things done. But in case of the machine learning, the computer, we make the computer learn from the experience and do the predictions based on that. So so you can let's take an example of Mario. You have played Mario. How much time did it take for you to learn and win the princess? So the question is, can the computer also learn the game by itself and play? So somebody hooked the controller. These are old video, but it still is a very valid example. So basically, somebody took the controller. So somebody, like, if you have to run Mario today, if you want to play Mario game, right? What you would do, the you will launch the Mario game inside a virtual environment, and then you can play on the computer. Similar to that, one researcher, what he did was he took the Mario game, started in a virtual environment, and then made his program play the game. So the program was observing what's there on the screen, and then press the keys and then observe whether it's going good or bad, and accordingly it kept on pressing the keys, and it maximized the score. Let's see how it goes. Okay, so what you are seeing on the screen is initial days, since as it starts playing, the program starts playing Mario, the it's kind of it has no information, no knowledge, and it just starting to learn, so it's just jumping up and down, and it's not doing anything. You can see on the screen these keys are being pressed, and Mario dies of the old age. And couple of plays, after thousands and thousands of plays, it is able to do a little better. You can see that it's able to start moving, though it's facing backwards and is badly stuck. Now, few more weeks, it learns to play. Okay, you can see it learns to do good job. It is able to move forward and having the intuitions. So it is starting to learn all of that. You can see here it is having no problems at all. And all of this, it has learned from the past experience. Nobody has coded it and so on. So you can see that it's having no problem at all in playing the game. Now, a few more weeks and he's expert now. You can see that Mario is going to play really well, you see? Look at that. Look at that. Now you're going to something amazing. What was that? What was that? The Goomba is falling on it, and then it just starts moving downwards, and then it wins it. So it figured out a bug in the game. It figured out the bug in the game that the game can't figure out who hit who, and it is exploiting that. Okay. What was that? There was another bug that you saw being exploited. Okay. So, so it learned all of these things that we never knew by the way of learning from data. And when it could not win a game, it paused the game. That's exactly like my cousins did when we played the game in childhood. When they were losing, they would just spoil the game and run away. Okay. So, I mean, cousins as in like siblings and cousins. Okay. So basically, this is how the computers or the software can learn. Software can learn from the data and become really good at it. So what exactly is AI? AI is an intersection of everything. AI is like objective. We are trying to create the 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 AI is like an objective. We want to build that intelligence like animals and humans, right? Though as of today, the terminology AI has become so common, and we always refer it to large language model like ChatGPT. Okay, so ChatGPT is just one part of the AI, right? Language intelligence. So, so basically, the AI is essentially overlapping the hardware. To achieve AI, AI is an end objective. The AI or AGI, whatever you want to call it, this is the end objective. It overlaps with hardware and then software. Under software, either you write the code by yourself or the software learns the rule, learns the game by using the data. And that's called machine learning when it is trying to figure out the logic by itself. And then inside machine learning, there is something called deep learning. Deep learning is one part of the machine learning where we use the deep neural networks or the machine learning models which are based on the animal brain. That's called the deep learning. Okay, so now the with that uh, mm, I want to invite Professor Tarun to talk about ChatGPT. Professor Tarun, would you like to? Are you around? See. Professor Tarun, are you around?
Yeah, yes. Thank you, Sandeep, for your introduction about AI, data science, and uh, how crucial role machine learning and AI is playing in the uh, day-to-day setting. So the topic essentially is ChatGPT and GPT-4. These are, as you're all familiar with, have really changed the spectrum of various applications or various problems we are working. So ChatGPT stands for Generative Pre-trained Transformer, and GPT-4 is the same Generative Pre-trained Transformer, but the version of the model is 4. So Transformer is one of the very advanced deep learning model which has come up in the recent years. So this deep learning is a very specialized machine learning algorithm, consists of very specialized neural network based machine learning algorithms. So which are bio-inspired algorithms, essentially based on human brain and the human visual cortex. So these algorithms are bio-inspired. And transformer model is one of the very advanced such deep learning model, which basically built a big leap in the AI spectrum. So these are known as large language models. So as you all know that these are developed by the giant, which is OpenAI. So OpenAI is one of the very, as you know, is the initial company which has actually come up with these different models for as an alternative, or probably it's coming off as an alternative to Google search also. So Google also developed various models like Gemini AI, etc. So, but these are multimodal AI. So, as ChatGPT and GPT-4, essentially they use the text input and they try to answer the concerns of the user. So, based on the text input. Of course, now they're also updating the interface with other modalities, but still they are yet to do that. So, these models are essentially used for natural language processing, essentially generating human-like responses, mimicking our human intelligence. Next slide.
Okay.
Thank you.
You want to take this up?
No, you can take it.
Okay. Okay. All right. I think I made a mistake. I was supposed to take from here, not the beginning. Extremely sorry for that, but never mind. So you will right with respect to most of the topics, right? In the machine learning and deep learning, uh, the topics will be taken up by Professor Tarun as well as Professor from IITs, and the engineering side will be taken up by CloudX Lab. Okay, so I want to give you an overview of the typical workflow from the perspective of the engineering in machine learning. Okay, so this is here I want to talk about a typical workflow from the industry perspective. How does it look like? So in the beginning of everything, we basically gather data. Now, this part has been going on since 2010. Most of the organizations in last 10 to 15 years have mastered the art of gathering data as well as they have gathered the data. That's what I am seeing in the industry as I'm working with people. I'm observing that people have mastered that art of data engineering. Okay, so they have gathered now the data. Now, this is one of the reasons why machine learning or AI is successful now because we have done that. So the typical workflow starts with gathering data. Now, how do you gather data? One is the real-time data, the data that comes at a fast pace, like when users are clicking on your website and millions of users are clicking, all of this data needs to come somewhere, right? That's the velocity of the data. To manage the velocity of the data, people usually go for, say, Kafka, the queue system. Kafka is a queue system whereby all of this data is put into the queue, and then on the other hand, there are listeners of the queue who save the data, right? And okay, and and how do you store such a large data? You store such a large data in, let's say, NoSQL databases, right? So usually smaller data sets, the specifically transactional data set, We used to store in databases like Oracle and my Oracle, PostgreSQL, the standard relational databases. And when the data became big, we started storing it in NoSQL databases, which is nothing but databases running concurrently on multiple machines, meaning one table, one table of the data is spread across multiple machines. Then we got HBase, we got HDFS. Essentially, HBase is an example of distributed databases, and HDFS is an example of distributed file system, like the file system that you see on your computer, C colon or D colon on your Windows. That's a local file system that's on one computer. But HDFS is a file system where some folders, some files are on one machine, some part of the file on another machine. So multiple machines collaborate together to make one folder structure, and that's HDFS. So to gather all the data at one single place, we use these tools. And we have been using these kind of tools for last 10 to 15 years, the NoSQL and the big data tools. And the traditional tools like Oracle and Postgres, we have been using since 1960s. So the whole story starts with gathering data because in machine learning, we learn from the data. Okay. Then the secondary process is of cleaning the data. Like you have the raw data in file system, you want to convert it into tabular system, or you want to clean that up. All of that, all of that happens using Spark, MapReduce, and so on. These are few examples of ETL. Before these big data tools or large-scale tools came into play, there were the traditional tools like Microsoft ETL or Informatica for doing the ETL. ETL stands for extract, transform, and load. But nowadays, everybody has moved to Databricks, Spark, or MapReduce. So this part is done. These two parts, as of now, in all our professional projects, are either done using Google BigQuery or AWS or Databricks. Okay, there are the components around the Databricks for all of this. Now, the basic analysis of the data is then done using, say, Spark SQL, Hive, and so on. Once you do the basic analysis, now the time starts for learning from the data. So there are quite a few machine learning algorithms such as Spark MLlib, GraphX, Scikit-learn, and R. All of these libraries like PyTorch, TensorFlow, they provide you with the ML algorithms and whereby you do the predictions and build the models. And once you're done with that, then you start optimizing, fine tuning, or scaling it up or making it better. And you might go for deep learning. So, machine learning, deep learning, and data analytics, before that, data engineering, data engineering, and so on. And then once you are good, your product is doing well, and you have fine-tuned it, the TensorFlow and so on, then you take it to production. Okay. So the way you think about this whole flow is this is where you're starting with, let's say, the data engineering, then the analytics, and then the machine learning and deep learning, and then moving it to production. Okay, moving it to production and deploying it. For deploying, you will require the knowledge of DevOps. So this is how a typical workflow looks like. In your project, your project might be only related to gathering data, only related to cleaning data, or it could be the full project. Okay. So it's essential for everyone to understand every piece of puzzle, even if they are only focused on one part. So you should know every part of this puzzle. That's why we have put one course on DevOps on CloudX Lab. You will also see the various component that you learn as part of the course. Like for example, our course starts with Linux, and the Linux is the core part as part of the This one, right? So Linux, when you want to move things into production, you need to know Linux and almost everything. So similarly, there is a chapter on SQL that helps you learn SQL so that you can do the data analysis and so on. And then the primary course, the core course, focuses on learning the machine learning and deep learning. Okay. Now, you might ask, like, what are the various careers in machine learning? I want to talk about the careers because it's very critical now. I keep on hearing every day from people that is it necessary to now learn software engineering when there is ChatGPT who can code for you? The answer is it is all the more necessary because because ChatGPT and OpenAI, not OpenAI, ChatGPT and AI and large language models, all of these new technology is going to automate and impact every field of life, whether law, whether medical sciences, and so on. I can already see the impact of large language models such as ChatGPT or Gemini or DeepSeek. I'm already seeing that impact. That in medical science, the the of correctness of data by LLM is way better than by people. Okay, so if you give a big document of a patient to a doctor and ask it that did this person have what kind of surgery did the person go through and so on. So if you have, and we conduct this large scale study on observing whether humans are doing better or the machine in extracting information, we found that the machine's performance is multiple times better than people. Okay, so a lot of manual work will be automated. And of course, the AI or machine learning would be considered a tool of any use only if it does better than human in certain domains, right? Every tool that we have been using, whether it's a hammer is stronger than human hand, right? So every tool that we have used and we are using, it's a tool only if it is better than humans in that particular domain. On the similar line, the AI is useful only if it does a better job than human at the language tasks. And therefore, you always have to consider all these things like tools for you rather than competing with a hammer, rather than competing with a car that I can run faster than the car, rather than competing with them, we have to learn to utilize them. We need to learn to drive these tools. We need to learn how do you utilize LLM to do various kinds of tasks. And for that, you need to learn machine learning. You need to learn computing, and there is no doubt about it. Okay, so rather than arguing that since there is a hammer, and I don't need to learn engineering because there's a hammer which can do everything. No, hammer can only do one part or drill machine can do only one part. Similarly, the language model can only do one part, that is language. But somebody need to guide it. Somebody need to 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 make to convert a very large problem into parts that can be solved by using AI. Okay, so it's very important for everyone today to learn machine learning, learn computing, and do not think about the aspect that you hear all the time. If you those thought leaders, they keep on saying kind of things that, oh, AI is going to replace the like, for example, NVIDIA's CEO said that, oh, there's no need to teach computing, no need to teach coding. No, that's wrong. That's misinterpreted. He didn't mean that, right? So because if you see NVIDIA's own job portal has all the jobs openings for machine learning engineers and computing engineers. Therefore, whether you're going to work in hardware engineering, mechanical engineering, civil engineering, medical sciences, everywhere, you need to know computing, you need to know machine learning. There is no doubt about it. So there are quite a few career options with machine learning, purely in machine learning, but there are so many different roles in your own verticals that are opening up every day. Okay, let's say, I mean, with your domain expertise and the knowledge of machine learning, you'll be able to do much better than anyone only with the domain expertise. Okay, so in core machine learning, there is machine learning engineer, data scientist, and machine learning researcher. Okay. Now, for a machine learning engineer, what are the character traits that I would look at? One is the person should be really good at communication. Then they should know how to get things done with the basic things like data cleaning and so on. Do they have an idea about the basic functionalities or basic operations? Then I take a look at, does the person has a good understanding of maths? And then I look at, does the person have good understanding of machine learning concepts? So these are the four large buckets that the questions in an interview come. Okay. And the usual process, I'm taking this example of process from the top organizations. And the way it happens is that the process starts with the screening, where you might see a simple coding questions or aptitude question. And then there is the second, the round, which involves, let's say, medium coding questions. Again, then the third round, first round is tech, like the coding, and then comes machine learning, and then behavioral. So, so you can see that in case of machine learning engineering or machine learning in data scientist, everywhere you will find that the coding questions are predominant. Okay, that's why as part of this course, we spend reasonable amount of time in learning to code. Okay, in learning to code. You might find this very interesting that the way the course is going to be, the beginning days are going to spend, we are going to spend on computing, like the how to code. Okay, and those of you who have already done coding, you will also find it very interesting because the way we have organized the coding part is that you will be coding your machine learning algorithms. Okay, the problem statements in coding are going to be related to machine learning. So you will learn multiple things at a time in the course. In like first 3 to 4 months, you will spend very good time, number one, learning maths, learning coding, and learning machine learning, all three at the same time. So all the problems that you're going to solve during Python course are going to be involving machine learning, maths, data structures, and Python understanding. Okay, so that's the most interesting part. I want to say that the one that is the one part that differentiates this course from every other course on the planet is those first few months of learning to code. Okay. Looking at all my friends, looking at all the past students, we realized that what people need to know and what my students need to learn is they need to be able to, code anything, right? If like what I observed that people have been asking in the interviews of a machine learning scientist, machine learning researcher, or machine learning engineer, they've been asking questions like, can you code this particular machine learning model? And or they give a little different version of it as a problem statement and you have to code it. Or let's say you have two matrices and you want to multiply them. Okay. Or you are given three equations and you have to solve them using a code. So all of these kind of questions are asked as part of the machine learning interviews. And these are important questions because even as a machine learning engineer, even as a machine learning scientist or a researcher, your job is going to be, you know, coding a lot of things. Even if there is just so many chat GPT and so on, who can code for you. But remember, you can get coding done by these tools only if you know what's going on. Otherwise, it'll be trash in, trash out. I have seen it multiple times. All those engineers who do not have the knowledge of what's going on and they use the chat GPT, they end up messing the entire data. They end up messing the entire problem. So it becomes very difficult to get the work done. Therefore, we have incorporated the first few months of the course are going to be dedicated to coding algorithms using Python and coding the maths part of it, like how do you do equation solving and so on. That's the part you're going to do as part of this course, or doing the interpolation, doing the curve fitting. Those are the exercises as part of our initial coding introduction. So even if you are good with coding and you have done coding, trust me, you're going to enjoy the first initial the coding kind of ramp up in the course. Okay, and this has been designed. The course has been designed from that perspective that you will become hands-on no matter from what background you're coming from. I can guarantee that you will become hands-on. The only request I have for everybody who is joining this course is that be open be open to just code. Okay, don't come to the class with the mindset of just listening. This is the most theoretical session that we have in this class. Rest of the things from next session onwards, you will be working in the class rather than you will be just watching the class. Okay, so the way the course is designed and structured is that you think of this class as a working session. You sit on a laptop rather than watching it on TV. You sit on your desktop rather than, being away from the screen. You have to be near the screen from the second class onwards. Okay, so keep that mind clear, keep that perspective clear. You will find that in the class there are people who are 60-year-old and there are people who are 18-year-old, and everybody is in the same place, and there are people who are absolutely beginner in the class, as well as there are people who are fairly professional, and everybody will be on the same level playing field. So the kind of thing that you will observe is the kind of problems that you will be solving is equally hard for everybody. Okay. And you will have a great time working on this. So the class is more like a gym where all of you have to work out. I would give lots of problem statement starting from simple to hard. Okay. Irrespective of from what background you are coming to, come to the class with the mindset that you are going to the gym. The more exercise you do, the better you will get at problem solving. So this class is not a content consumption. It's not Netflix. It is a gym class. Okay. So work with me from the next session onwards. I would want everybody to be with the notepad and pen along with their laptop and the keyboard, not the only screen with the remote. Okay, and everybody has to keep their cameras on and work with me. Okay, work with me. Trust me, I have seen enormous success of the previous EICT batches and the IIT Roorkee batches. Enormous, when I say enormous success, most of them have got really decent job. So I would request everybody from second session onwards to work with me in the class. Okay. And basically, here I am just giving you the same breakup that I have given. So as part of the machine learning, people judge your overall understanding of mathematical concept like linear algebra, statistics, probability, and calculus. And therefore, we have included parts of these various verticals cleverly into our Python codes. Okay, so instead of saying differential calculus is X, Y, Z, and so on, we say that okay, here is a Python function. Can you write another Python function to differentiate this Python function? Right? Similarly, with respect to probability, you have exercises whereby can you choose, can you design a dice, like I'm just giving you sample questions, like design a dice which which give or design a coin. We start with the coin, design a coin or design a function that is called coin that prints 90% time yes and 10% time no. Okay, and so on, or design a method which increases the likelihood of one thing over the another, like the things like temperature that which is there in LLM. So each of these mathematical concepts are, you learn them by coding them. Okay, and as part of this course. Similarly, you learn all of these libraries, like the role of NumPy, Pandas, Matplotlib, Keras, and so on. You learn most of these functions by actually coding them. For example, instead of saying, like we learn in one of the chapters, there's one exercise where given a big photo, shrink it to half the size. You are given a photo without using any library. Can you shrink it to half the size? Then the next question is, given given a photo, can you make it 2x the size or 3x the size? And there can be multiple algorithms, and you have to come up and code it. So when you are coming to class, come with the mindset that you're going to invent something today. Okay. And most of my class, they actually become inventors. I can share that data from my previous class that most of the people are doing so amazing wherever they're going. And just because they learned the entire of machine learning like an inventor, whereby they are able to see how to create something from scratch. Like, how do you create a function that can do the square root without using any library? So all of these things you will learn from a very first principle perspective as part of this course. Okay. So the overall understanding of machine learning and so on. So this everything is covered as part of this course. Okay. And then we have the supervised learning, and we will be learning how to build models. And these things you'll be able to do it very quickly. And we'll be learning how to do clustering, PCA, and the unsupervised learning. So as part of this course, you will learn the fundamentals. You will learn the machine learning, deep learning, and advanced algorithms. Then you will also do the supervised learning and end-to-end project. You will see in the course that's already there. In my courses, you should see all of these chapters already. And right, so you should have good understanding of these parts. That's what people understand, and therefore we have included most of these things as part of our course. Okay, so that's pretty much from the class perspective. I will see you next week at the same time. All right. So thank you, everyone. And any questions before we there is a nice question. Can you please suggest a good book on how human mind learns, and maybe how today's LLMs are trying to replicate? Very good question, Ravish. And this question, this question that you have asked is very, very insightful. And and as part of this course, we will answer this in parts. Okay? So first, like one of the assignment is going to be, if imagine that you have x is 1, y is 2, x is 2, and y is 3. So if x is 3, how much y is going to be, right? Now you have to code this. Okay? You have to code this as part of the exercise. Further, we have created something called ancient secrets of prediction. Okay, ancient secrets, ancient secrets of prediction, exactly for this. Okay, and it's a very interesting exercise that we are trying to do, and you should watch these videos. Okay, so we talk about this part as this exactly using very simple examples. Okay. Okay. So, and as part of the Python course, what you will do is you will learn to code it up. Slowly, slowly, you will learn to code it up. First, you'll solve a very simple question, then hard, and you will internalize how machine learns. Okay. Now, how machine learns, as well as, yes, human mind learns, but the way human mind learns is a little different from the way computer learns. And that is something that is I'm not an expert on human mind, okay, but quite a few researches are there, and one of the things that we discuss as like one of the things that we cover in the reinforcement learning of this course is things like curiosity. We learn by the way of curiosity. And this is the closest you can get to in computing to the way human mind learns. Okay. So I hope that answers your question. I would have to look at, the, I have not seen the things other than the machine learning when it comes to thinking, and I mostly focus on that. Okay. All right. So I'm looking forward to see you in my, class that is starting next week, and it's going to be one of the life-changing sessions for you, life-changing courses. I can guarantee that. This is based on the feedback that I have received from people in my class. Uh-oh, I'm hearing the echo. Okay. So all right. Any other questions before we end? Question is, I have two questions. Can you please talk about placement? Yeah. Assistant PET. Yeah. So, so the way what we do usually is we have something called a placement eligibility test. This is common for all our students from all our batches. You can write the placement eligibility test as many times as you want. Okay. Every 6 months we run placement eligibility test. And then based on your score in the test, we we basically connect you to the industry. Okay, if you have performed great and somebody is looking for that kind of candidate, we connect you there. Okay, I hope that answers your question, Samriddhi. Question is, what book do you suggest? We follow this particular book, Hands-on with Machine Learning and Deep Learning, okay, by Aurélien Geron. Okay, this is this is an old version. I'll just look at the new version. So this is the new version. This is the new version. We follow this particular book in the class. It is again an old version. This book, this the complete hands-on book. We like this one. So if you are interested, you should buy the book. It's actually pretty good. It's a good mix of hands-on as well as theory. Okay. Professor Tarun, would you have recommendation for any other book for students in this class?
Yeah. Hi, Sandeep. So, I think there's a book by Christopher Bishop on pattern recognition and
Oh,
machine learning.
yes, yes, that's the
Yeah.
pattern recognition, right?
Yeah.
This one. Yeah, that was my first book. Okay, this one. This is the popular textbook. Okay, popular textbook for this. Wonderful. All right. Thank you everyone for wonderful set of questions. Any other questions here? I would expect more questions. All right. Usually our sessions and classes are very Q&A centric and hands-on centric. This is the only kind of most theoretical session that you would attend. Rest of the classes are going to be much more discussion centric as well as focused on focused on the hands-on. Okay. So feel free to ask questions and yeah. All right. Anything we should be prepared for the next session? I would say go through LMS, finish Linux chapter, Linux chapter, and for the next for the next class, you should know how to count. Okay, the next session is going to be how do you design a number system in a base. So next session, we will spend time on designing our own number system. Everybody would choose a base, and in that base, you will write countings. We call this chapter learning to count. And as part of that chapter, you will first write down the numbers, then you will write down additions, subtractions in your number system. Okay, and do the multiplication. You will write the tables in your number system, and then you will learn to divide in your number system. Okay, it'll be your own number system that you will invent. That's the first chapter, and we call it learning to count. You will see that impact of that chapter on everything that you do as part of this course. You will see that you get better understanding of information theory, you get a better understanding of log, and this simple chapter called Learning to Count is going to be more about the basics, and you will see that a 10-year-old as well as 60-year-old would perform equally well on that chapter. Okay, so see you next week and at the same time. All right. A question from, okay. A question from someone is that the previous batch session recording have been removed from CloudX Lab website. Will it be available again? It'll be made available to you guys. Okay. So I can ask team to share previous batch recordings and right. That was complimentary. Just we have removed it from learning management system, your my courses because it might be causing a lot of confusion. So we kind of removed it. Okay. So, but if you guys want, we can provide that as complimentary. There's nothing to worry about that. Okay. A question from Samriddhi is, uh, right, a silly question maybe. There's no such thing called silly question in my classes. Every question is important, and you will find that your questions are actually helping everyone else in learning rather than wasting time. Okay. So the way we look at the questions in this course is that every question is important and every question actually helps everyone else. The reason these classes are successful and popular, because uh, quite a few people gave me this feedback that when they came to the class, when they came to the class and there was a discussion and somebody asked a question, that thing actually helped him in clear the interview. And that's why these classes are known for the silly questions. And you will find the silly questions are not that silly. Now, coming to your question, but would learning Linux on my own be easy for someone who has no background in Yeah, trust me. You'll have good time. Just go through the LMS. You go to CloudX Lab, my courses, click on Linux, and then finish it off. I can guarantee that you will, no matter from what background you are coming from, you will finish it in at max one day or maybe 2 days. Okay, so don't worry. It's only the first 3 or 4 exercise you will struggle with, you'll get used to, and that's when your learning is happening. Okay, you are getting used to that terminal, and that's the most important part. So I guarantee that you'll be able to handle by yourself. Trust me. Okay. All right. Now, are there any fintech projects in the course? There are a couple of them. One of them is predicting the stock prices. That's part of the recurrent neural network. Okay. And yes, feel free to choose any project from fintech and work with me throughout the course. Okay. So feel free to do that. Okay. As well as there will be a project for you where you will have to solve it by yourself by end of the course, and that is what you have to present at IIT, and based on which you will get the certificate. So basically, there will be a choice of project that you want to do. Okay. All right. Question is, please make those previous batch sessions available on website. It will be very helpful. Sure, I will make it available. Thank you that you found those helpful. I'll make sure that my team, Gargi, if you are listening, you could make it available. Uh, Question from Smriti is, aptitude training for PET will be provided. Basically, this course will make you ready for the PET. Okay. All right. And a question from Ravish is, are we going to follow the sequence as listed under course topics for weekly session? Yeah, mostly, roughly, that's what we will follow. Okay. One last project is your choice. Yes. The last project that I talked about, the one that you present, is going to be your choice. Okay. Our question is, any team sessions? Most of the classes are considered team sessions, but what usually happens is most of the students from previous batches, what they did was they created their study groups and they basically get together a couple of times in a week at their own time, and then they have the group sessions. Okay. And that's a fun way to learn. I'm so happy that my students from previous class have created these nice groups, and they work together. And yeah, I'm really happy that the person who knows a little more would help the other person, and then that's how people are learning. I never imagined that that would happen. Okay. So that's the success of the previous batches. All right. So I hope I answered your questions. Okay. A question from Ram is that to make right most of these sessions for next 8 months, how would you suggest we should plan our study time? Should we be learning additional material and courses? So I would say this. So as part of my classes, I would be giving exercise that you'll have to do all of those exercise. Second, you have the my course in my courses, you have all the content, so whenever you get time, just go through it and make sure that you finish the projects. There are quite a few solved projects, which are guided project, we call them, and you can do that. Like for example, uh, celebrity like you. You have to find one celebrity from IMDb database who looks like you. Okay. So out of let's say 1,000 celebrities, you have to basically write a program that can find a celebrity like you. Okay. Similarly, there'll be a project where in the beginning. So what we have done is most of the engineering project does not require too much of understanding of machine learning. We have moved them to Python side. The celebrity one is a Python side. Then deploying a machine learning model is on Python side. So most of these projects that do not involve the deep understanding of machine learning, that which only involves the understanding of Python, Python, that those will be part of the Python course only. So immediately after, let's say, right during this month of Python, you will probably learn you will learn how to use the generative AI. You learn how to do sentiment analysis using LLM. All of these parts will come under Python. Okay, so a lot of things would happen during the Python course itself. Okay, so I would request everyone to, spend at least, say, 5 hours of study time, 4 to 5 hours of study time during the week. And and during the class, come with a mindset with exercise. No matter who you are, you will find that in the class there would be CEO of some company, okay, or like the general manager having like 4,000 people reporting to them. So there'll be all kinds of people in the class. So come with that open mindset to work, no matter who you are from your background. Okay, so that would be my strong suggestion. And whatever is needed to learn things, that content will be provided. But my request would be that don't get lost in chasing the terminology, chasing the just one tag. Somebody said RAG, retrieval augmented generation, and now everybody just chases that. Instead of that, we go in an inverted way. We go slow and the deep at the same time. Meaning, we do let's say, we do a simple uh, something. We have a chapter called computing distances, right? You basically give in two numbers. How do you compute the distances? That's a Pythagoras. You must have heard about Pythagoras theorem, right? So learn that part. How do you code it up? And then at the same time, you will use that to do the sentiment analysis. Okay, so the chapters are going to be strange. Okay, they will be easy and difficult at the same time. Okay, and for expert as well as for beginner, there will be something to learn all the time. So come to my class with an open mind, as if you are going to a gym. You are not coming to a theater. Okay, so that's how my honest request to everyone who is joining the class is work with me. Don't just listen to me, work with me. Okay, that would be my honest suggestion. And rather than just assuming what I'm saying, ask the question that comes to your mind. If what I'm saying does not make sense, just stop me and ask. Most likely, the words I'm using are not suitable for you. I will choose different set of words for explaining the same idea. Okay, so come with the mindset that you are going to have discussion, you're going to have exercise, and it's a place for open place for everyone to have a healthy discussion. Okay, so that would be my suggestion for everybody, and allot some amount of time every day, maybe 1 hour every day, uh, to finish all the work, all the exercises. Okay, and the another strategy I would say to all of you: be curious rather than judgmental. Okay, when I say curious, okay, when I give you an exercise, rather than saying that, oh, I don't want to do learning to count. Learning to count is just a simple thing. I have already done the learning to count. Rather than looking at it this way, then say that, I mean, work like this. Let me give it a shot. Let me give it a shot. Let me be a child. Let me be a kid. The way you were as a kid, that you played game without being judgmental. That what is there in it for me, right? rather than saying that what's there in it for me. Just play the game, just work with me, be curious rather than judgmental in my classes, right? Ask the question rather than feeling that is this a question? Is this a good question, bad question? Don't worry about that. Whatever comes to your mind, ask that. Okay? That's the only, important thing that I would like to say. Further, make your study plan. Dedicating 1 hour every day is going to be fairly hard for you. Okay? And you have to make sure that you manage that. Okay? You manage that. Because this course is extremely, how should I say? I mean, it's better than any Stanford or Harvard course. Okay? And I'm proud to say that. Okay? You can just compare the outcomes of this course. Okay? And I mean it because this is going live. This is public YouTube. And I have seen the feedback of my course. I've seen the students who have done my course. So with that ambitious plan, the only way I can achieve the ambitious plan of making this course really powerful, okay, is to work with me, be curious, be disciplined every day, spend 1 hour on you, no matter how. Okay. All right. And yeah, so work with me, trust me, work with me, and you will find yourself as a different person. And you can see if you go to Google reviews, read the reviews by the people who have attended this course. Okay. So yeah. All right. Perfect. So head over to the my courses. If you have already enrolled in the course, head over to my courses. Start from the top and start going there. Okay. Like it's completely okay if you are moving very fast. It's completely okay. And and if you are stuck there, you have a question, just ask that question in the class. Don't think that, oh, you are way ahead and others are behind. Don't worry about it. Okay, I'll manage all of that. Okay, so go at your own pace. It's a very good thing if you are able to go at a faster pace. It's not a bad thing. And I will give you better assignments so that you become even better. Okay. So yeah. So work on the course rather than just watching it. Okay. Think of it as a gym class. Okay. All right. So thank you everyone. With that, I look forward to see you next week at the same time. Wonderful. Wonderful. Thank you, Professor Tarun. Thank you, Professor Manhas. Thank you to my team to organize this. And from the next week, we will continue from the learning to count. Okay. Thank you, everyone. Bye-bye.
Bye.